will be better next time I try. And even if I still can't do it yet, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too long. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, before long, before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? We are back at it again with another day in the 100 days of Rootkit mark. We are officially past the 1/3 mark, all right? We are chugging along this and at another amazing, awesome day. Now, before we go further, I want to ask, how was your guys' day? Was it good? Shut up! Was that rude? All right, don't worry. We got a lot more Reed stuff coming along here today, because today is all about interrupts. All right, interrupts, trap handling, and exceptions. All right, and we're gonna talk all about them. Exceptions. Was that the other one? I forget now. All right, let's get through the rest of our intro here. Where do I want to go? If you don't know, we are Rootkit, a non-profit here in the US of A. Now we're completely registered IRS, so you can come donate to us and let us be your tax haven. All right, get those nice tax credits. That's what rich people do. All right, if you want to be rich, you will get your tax cuts. All right, we have a habit of doing things for free a lot, so we got our week 5 giveaway going on right now. You got 24 hours left to enter. All right, we're giving away one of our amazing sweaters. It doesn't cost you anything. You just fill out the form and then you can enter to win. All right, not the Twitch stream. What am I doing? I'm on autopilot right now. All right, 100 days of Rootkit. This link right here, let me paste it in the chat. This one, and where's the other one? There we go. If you want to be a generous donor of ours, or maybe just avoid taxes, you know, I'm totally down for that, then you can donate to us here and fill up that bar above my head. We have a generous donor who is matching all donations 1-for-1 for the first 10,000 donations. It's super awesome, super awesome. Depending on how much you donate, you can unlock certain rewards, like our stickers, our epic collab t-shirt, which is right here. Look at this, super epic. And our awesome sweater. All right, so if you don't win a sweater, you can just buy one right here. All right, and we have a bunch of pillars when we hit certain milestones, like teaching for 24 hours straight, shaving my head here live on stream, and then shaving my beard, which we're not going to get to, and that's okay. All right, we don't need to get there. I don't want you guys to get there. It's not a challenge to get there. Right, we just don't need to. No one wants to see me without this beard. All right, why is it there? Because my family they don't care for the beard, all right? They want to see it go away, all right? They make fun of me all the time for it. So that's why it's there. All right. If you want to follow along, hey, guess what? Like I said, we have a problem with giving stuff away for free. And if you're enjoying this typically 200K, or if you go to college, 100+K course, hey, a donation here or there might be nice, but you can follow along. We've laid everything out that you need to know on our comp sci cert roadmap here on our GitHub, all right? Now, we're just going through bullet point by bullet point, pretty much as if you were, you know, someone off the street looking at this and wanting to learn each item yourself. So we left off in the end of operating system here. We're almost done. Off to the programming parts, all right? The part that everyone wants to just jump right into, all right? And then they get themselves trapped because they didn't learn the foundations. Interrupts, exceptions, and trap handling. All right, that's what we're diving into first, because yesterday we finished up talking about some process internals, particularly about processes, threads, and these things called race conditions and deadlock conditions. We can use these rude tools here to help with relieving those issues. All right, so that's what they exist for. Any questions so far? Any questions from yesterday? Again, as always, if you guys have any questions, just go ahead and drop them in the chat. Let me change this one to live chat so we don't get any mess ups. If you are a Patreon or Discord premium member, I am in the Discord, so you can at any time hop in there and ask any question verbally if you like. If not, you can just ask them on the streams. All right. Let us move along here. Interrupts. Let's see. So interrupts, exception, and trap handling are all ways that you can utilize your OS to do more of a brute force operation, and it's in coordination with the underlying drivers or actual hardware. So there's things built into your CPU for kind of throwing these alerts, and they are a forceful mechanic. You don't want to throw an interrupt just at any time, because if you're using it in your normal everyday logic, which you could have it as a part of your normal everyday logic, it will definitely cause some inefficiencies in your application, because it's not an efficient process when you do these. They are rather hardcore. All right, so interrupt and accepts will divert the processor to code outside of the current execution flow. All right, so if you're supposed to go, your code says go from A to B to C, if you throw an exception or an interrupt, it will basically be like, oh, wait, whoa. Hold up, buddy. Cancel this. Get out of here. Where's the cancel culture? Bring it in here. Cancel all this shit. All right, we're going all the way over here now. All right, we're doing things my way. It's you to stop forcefully whatever's going on and then cause something new to happen. Usually what is new that happens is you will hopefully have some handling on it and handle the exception or the interrupt gracefully and end the program. Typically that's what you would want to do. Now, just because an interrupt or an exception happens doesn't mean a program needs to end. That's usually just the most common thing that happens. But if you don't handle it gracefully, then a program will crash. That's typically whenever you see the violent crashes where you're just minding your own business on your computer. You're just clicking along, doing whatever you're doing, and then all of a sudden it's gone. And you're like, hello? That was rude. How dare you? All right? Your computer had an exception that came up, and it brutally destroyed the instance of the program that was running. It destroyed that process and all the threads underneath it because there was an exception that happened without proper handling. All right, so that's something to be aware of. Now, these exceptions that are thrown, all right, or these interrupts that are thrown around can happen automatically at the operating system. So the kernel itself may throw these exceptions at you for doing something it did not like. It's going, no, you ain't gonna do that, not today. You also can throw exceptions or interrupts around if you would like, and take control of that yourself. Usually when you're doing that, it's because you want to gracefully have something happen, because hopefully you're throwing them on purpose, or at least trying, if you're going to let the program chaotically collapse, hopefully you're throwing these in order to provide further information for why it crashed. All right. Typical reasons things may crash: there's not enough memory, not enough disk drive space, you're trying to open a file you don't have permissions for. I feel like there's some more common ones. Maybe typing issues. We'll see here in a second. But anything else I need to... Yeah, so trap handling is just for handling those exceptions. Usually they're just called handlers. All right. But we'll see more of it when we get into Python, and I think we're going to hit some C. We're going to do Python. No, I don't want to. But maybe we'll take a look at Java in the programming bit, and maybe finish up with some HTML and CSS. We'll see. We will see. So interrupts are, let's go ahead and actually Google this and see what the Googles has to say about it. All right. Programming interrupts. All right. So let me zoom in here. Are there any questions so far? Let me see here. Just joined today. Find it super coincidental that you're covering the same topic we covered today in my class, in my intro to OS class. Yep, everything we teach you here will be in the same as what you're being taught at your school, at any college. We teach it all, plus more based off of what current companies have requested or have in their job listings. Deadlock usually happens due to a race condition. It can, yes. Sometimes. It depends. But deadlock means that that pretty picture that we had before. I'll get into that maybe a little bit later. We'll do a quick review. But it means that things are frozen because everyone's kind of pointing at each other. It's like that gun duel scene. Everyone has their guns out, pointing at each other, and no one's doing anything. All right. So an interrupt, Google says, an interrupt is a signal emitted by a device attached to a computer from a program within the computer. It requires the operating system to stop and figure out what to do next. An interrupt temporarily stops or terminates a service or current process. All right, that's the big thing. Is it's brutal. All right, it will just stop and say no. I don't like what you're doing, so we're stopping right here. We ain't moving a step forward. All right. This is what you do. So when we talked about the terminal here, so let's bring up terminal and let's go back to our Ubuntu instance here, and let's go back and talk about kill TAC9. All right, the fucking nuke that we can launch on things we hate, especially orphan processes. We get rid of all the orphans here. All right, except you, Susana. You're the only orphan we can keep here. All right. Let's see here. If we do our PS-TAC elf, we can see our processes here that are running, and if we want to kill one, we can try to kill it gracefully. That's just going to be saying kill and then putting the PID. All right, I just made up that PID. You know, again, PIDs are the process IDs. That will send a interrupt. All right, that's what we saw there, the different TACs that we're able to do. Those are different types of interrupts. We can send the program to kind of be like, hey, it's time to close. It's kind of time to stop. But you can build trap handling in your program to handle those. All right. And so usually when something isn't dying immediately, it's probably a some trap handling that's going on to kind of handle it from crashing. So that's why you bring in the big guns, kill TAC9. All right. And that's going to send the sig kill command or interrupt over to it. What was the man page for it? Was it signal? Signal. Let me see if I remembered correctly. I think it was signal. Please tell me it was signal. God, why is this one so long? Here we go. So you can see here all the different types of commands that you can send over to it, and TAC9 is going to be your kill right here. You want to kill it immediately. All right. So these are all different types of signals for those interrupts that you can send. Some of them are like very useful. Like some of them were sig up. So this one's for, like it says, illegal instruction. There's sig up somewhere in here. I can't remember where it is right now. I thought it was earlier than this. Oh, right here. Whew. Sig up, which is typically for, here we go, it says right here, hang up detection on controlling terminal or death of a controlling process. All right, typically this will, the logic that goes with it is kind of like restarting it. I don't know, there's just various different ones here. Let's move forward. All right, so the big thing is interrupts are primarily generated by I/O devices. All right, and they're commonly referred to as hardware interrupts. That's the big terminology for knowing about the interrupts. And then exceptions, on the other hand, will be software driven. So interrupts are going to be more hardware driven. Exceptions are going to be software driven. They both accomplish the same task. They just come from different sources. Alrighty. Any questions like that? Yeah, a good example would be trying to divide with 0. You can't do that, so that would cause an exception to pop up. Now, things like your calculator may handle that, so if we bring up good old calculator built in the OS, our favorite application on here, all right? If we try to divide 10 by 0, you'll see an error has happened. this program is gracefully handling that exception that happens and will print out this instead. Any questions on that? Just remember the big terms here. We are going to revisit this when we get into programming, because we will talk about and go over how you can go about sending exceptions and handling them. Let's see. No new questions, so let's move forward to trap handling. All right, trap handling is usually referred to just handling, or you have a handler, and that is just controlling the interrupts and the exceptions that happen on your OS. So the operating itself will perform this to a certain extent. There is a general catch-all one on your computer. All right, your OS shouldn't crash that often, but again, it's kind of hard to catch all of the bugs in an operating system, especially when some of them come due to faulty hardware. So when occurrences like that happen, usually the OS will have a big catch-all. All right, that catch-all for Windows would be the blue screen of death. All right, that will happen because that is a massive trap handler that's going to sit there and handle any big issues that happen that cause the operating system itself to fall due to exceptions or interrupts. All right, it will handle it as gracefully as it can, and by that it's going to analyze what happened, collect data, and send it off to Microsoft for further analysis. That's what it's programmed to do. All right. Any questions in regards to that? Yeah, in Linux, the blue screen of death equivalent would be a kernel panic. Kernel panic, because it's freaking out. It's like, what did you just do? So this is what a kernel panic would look like over in Linux. You'll get some type of printout, and you'll see on it, on the blue screen of death and on kernel panics, they will typically have information that you can use to debug the problem. It's not like, well, typically, this can happen, but it's not usual now where it will just crash and be like, it crashed, don't know why, we're restarting, sending information to Microsoft. Usually it will tell you, and you can usually figure that out. It's not always the case. Sometimes it's kind of a mystery. My computer was crashing a lot for the last several months, and come to find out, one of these RAM sticks are faulty. I don't know which one. I haven't taken the time to test both of them, but at least one of them is faulty, because I've not had any issues since I pulled these out, and it would cause like 5 different errors to come up when I blue screened. But there is information. Any questions on that? So again, we'll get into this more and when we get into programming, but interrupts and exceptions are the same thing. In general, they're signals being sent to stop something from going further. Interrupts are going to originate from hardware. Exceptions are going to originate from software, and handling is just handling these two things gracefully. All right, let us move on here to device drivers, shall we? So device drivers, again, will typically sit above the kernel. All right, they'll be above the kernel in our little layer scheme, our little rings topology. So they'll have pretty high-end privileges. They're able to do things in typically a God mode specifically for their hardware. And you will have to go through them in order to interact with the underlying hardware, like a GPU, for example. So there's several different types of drivers. As you can imagine, there's going to be device drivers, which are going to be input-output based drivers specifically for things like your CPU, your GPU, and any other devices you may have plugged in. There's also file system drivers, which are going to help interpret what you're trying to do and be the middleman in regards to how you interact with whatever hard drive is there. These drivers are going to be great for when you're using things like an old disk drive or a solid state drive, because even though they are completely different hardware wise, the drivers make it seem to software that they're exactly the same. And that's what we like, is that compatibility. Not having to change anything we did. We can just keep chugging along at our life without any types of weird alterations that we would have to make. And then the last major one would be things like network drivers. So this would be, for example, the port on the back of your computer to your computer that's connected to a NIC that would then talk out to the network. You will communicate with those drivers, and that driver will then handle exactly how it's going to send the data across the network, because it is a little bit of a conversion from the actual wire to your hardware. Any questions in regards to that? All right, let us move on here. So Windows and Linux both implement drivers. They both have device drivers as what they call LKMs, right? Loadable kernel modules. So drivers can hook in with the underlying kernel. Let's see here what Wikipedia has to say for it. So LKM is a object file that contains code to extend the running kernel, so-called base kernel of the operating system. LKMs are typically used to add additional support for new hardware, such as device drivers or file systems, or for adding system calls. So again, like I said, the rings topology that we looked at, kernel at 0 and user at 3, is nice for organizing how everything works, but in reality, it's not like that. In reality, things are a little bit closer to each other than the pretty pictures will make you think. And like I said, the drivers will typically run in a God mode in order to interact with the hardware. So they're going to be typically doing this because they will be additions to the kernel utilizing LKM. So loadable kernel module, that's your drivers, all right? So we just talked about device drivers. That's going to be for new hardware, IO related devices. This is going to be for your new hard drives and so forth, your disk drives. Then this is going to be for things like your NIC or any way you want to communicate over a network. Any questions on that? So if you have any questions, you can just go and drop them at any time. I'm constantly looking at those. Then we got Windows. We've talked about it a little bit, HAL, or hardware abstraction layer. Now this will sit below the kernel in Windows, and this is going to be doing a lot of the communications between the hardware and the kernel itself. It's kind of a driver for the kernel, right? Let me see here specifically anything here we should mention. Let's go ahead and just look up HAL and see what the Googles has to say about it. Well, apparently there's a company here, Halliburton Company. Invest today, all right? All right, HAL hardware abstraction layer. So let's go and look at this again. This does not seem correct. Hardware. Microsoft HAL. Don't bring up the HoloLens, I swear to God. Alright, we'll look at this. I thought we had a nice little Wikipedia article last time. So Windows runs on, this is straight from Microsoft themselves. So this is in regards to the library for HAL. Windows runs on many different configurations on the personal computer. Each configuration requires a layer of software that interacts between the hardware and the rest of the operating system. Because this layer abstracts, aka hides, the low-level hardware details from drivers and the operating system, it is called the hardware abstraction layer, HAL. Developers are not encouraged to write their own HAL. If you need hardware access, the HAL library provides routines that can be used for that purpose. Routines are going to be functions. It's going to be the API that you can mess with for the underlying calls and interactions with that hardware. Now, they're not saying you can't do it. You can. And some of you guys may end up writing your own drivers and so forth. All right, it's completely doable. They just don't encourage it because if you mess up, it's usually a pretty big mess up, especially if it's in production. It could mess up and ruin a lot of things. It could add security vulnerabilities, XYZ. All right, so hey, it's your own hardware. You can do whatever you want with it. Go ahead, and make your own. They just maybe just don't do it on your main machine. Do it on I don't know, Raspberry Pi or something. Routines that have interfaces with the HAL directly are prefixed with the letters HAL. For a list of HAL routines, see this link. All right. Anything new here? We got our pretty picture right here, which we've already seen before. But it's basically a big boy driver. All right. That's included in your operating system. Any questions on that before we move forward? So Linux is going to have these things instead because they don't have a HAL. All right. They're going to be utilizing these things called block devices and character devices. So let's go and check out on that. Let me double check the chat, make sure there was no questions. All right. Come on, Wiki. They're going to be in the device files. Is this where we're going to live? Again, when we're in pretty deep topics here, but not even for deep topics, but in programming in general, we're going to teach you specific terms. Doesn't mean that's the term everyone's going to use. As you can see here, within the same Wikipedia article, people will call things several different things. All right. Best example, GIF or a GIF. All right. What is it? The owner says a GIF. So if the owner makes it, the owner gets to call it whatever they want. So it's called a GIF officially, but lots of people want to call it GIF still. Are they wrong? I don't care. All right. But we get that a lot in the programming world. All right. So if you ever are searching any of these things up and you see a slightly different verbiage, as you've seen plenty of times on our 100 Days of Rootkit stream, doesn't mean you're in the wrong place. It just means that they may call it something slightly different. There is no consistency. Again, like I've mentioned before, there is no government organization. All right. There is no codes like building codes for the programming world. It is absolutely just anarchy. Anyone can do anything they want at any time, however they want it, and they don't need to listen or respect anyone else. All right. There are no rules at all. You can do anything however you see fit. There are instead bodies like IEEE, for example, that we've talked about, which will recommend how you should be going about it. But not even a lot of companies go about that, as we saw. I forget who mentioned it in our chat. This was a while ago. We were talking about floating point numbers, and they brought up how there's a different type of floating number. There's a different type of floating point number standard they had a question about, and when we looked into it, we saw all the different types of standards of floating point numbers that exist, which I can't remember if it was on the floating point page. I think it's on a different page than this one. I think it was on this one. But regardless, there was that standard, there was the IEEE standard. NVIDIA themselves had, I think, like 3 or 4 different types of layouts for their floating point numbers. So again, no one has to listen to each other, all right? They can do anything they want at the same time. It's just very cost effective and convenient for end consumers if they do. For example, USB is a great example. You guys talked about USB a little bit in your hardware area. Before USB really grew in popularity, there were lots of different types of formats for plugging in devices, like SCSI and the FireWire, and I'm trying to list them all. There's a lot. There's a lot of different ports that used to be used. USB, and they were all proprietary. Probably the most famous one that's still around today would be Thunderbolt. But Thunderbolt is kind of okay because it uses USB 3 and it uses USB 3 and it works over USB 3 formatted wires in order to deliver its new its higher speed. USB was great because they were different. Everyone else was making these proprietary plugins, but USB was open sourced, it was free, and anyone could potentially end up using it. And it ended up winning out. Now everyone's pretty much on USB 3, so it's very convenient. Alright, we really took a deep dive there off to the side. Let's get back into block devices. Y'all can yell at me at any time if I start doing that again. Help me out here, internet. We can look at this overflow and the Red Hat article, and of course the Wikipedia one is all the way down here. Let's take a look at these ones first. I know many examples of block devices, so this kind of reveals here, right here. So in kernel, in Linux land, block devices are going to be referring to devices like your hard drive, solid state drive, anything that you can read and write to is going to be a block device. Let's see if there was any insight that was given by this answer. Probably you will never be able to find a simple definition for this, but in the most general and simplistic way, if you compare a character device to a block device, character device is the other thing we need to talk about. You can say the character device gives you direct access to the hardware, as in you put in 1 byte, that byte gets to the hardware. Of course, it's not that simple in this day and age, whereas block devices read from and write to devices in blocks of different sizes. You can specify the block size since the communication is a block at a time. There is a buffering time involved. Think of block devices as a hard disk where you read and write 1 block of data at a time. We talked about that already. And the character device is a serial port, like a USB. USB, Universal Serial Bus. You send 1 byte of data and the other side receives that byte, and then the next, and so forth and so on. All right. So in general, your character devices are going to be typically things like your keyboard, and your is a monitor a part of it? Monitor, I'm pretty sure your GPU will fall into that category, etc., etc. So let's see what Red Hat has to say here. And networking devices. Networking devices would fall into character devices. Doesn't look like much here, but essentially they're split up. Let's see if there's pretty pictures that go along with it. I like pretty pictures. Alright, that's just reinforcing block. Let's see, block versus character device. There we go. So I guess your speakers also will be a part of your character devices. All right. Not sure whether this one is correct in regards to separate being network devices, but I digress. The big point is Linux doesn't have a how. They use other things called devices. That can be a block device or a character device, for example. Blocks are going to be for your hard drives, and characters are going to be for typically everything else. Any questions on that? And then we're going to move on to system virtualizations, which, after going through this with you guys on this run, maybe we should move it towards the beginning more, because we have talked about VMs already, and I know some of you guys were a little confused when we did talk about them. No worries here. I enjoy the rabbit holes. Yeah, thanks. That's my autism kicking in. All right. Just going down and down and down. All right. So, if there are no questions, go ahead and drop any questions you guys have questions. If you guys don't have any questions, we'll go ahead and move on to system virtualizations. So, system virtualizations are absolutely amazing. They are so epic. All right, they run the world as you know it today. There's a lot of things that run the world as you know it today, but this is pretty much the fundamental founding base software. All right, because we just talked about interrupts and how they could be bad. You can get a blue screen, etc., etc. Imagine you're running a server on some hardware. You might be paranoid all of the time that it may blue screen. Something may be happening. Someone may hack it and get access to your box and valuable information. How do you avoid that? Well, the thing is virtual. All right, virtual reality. All right, that's what the computer scientists for the last 2-3 decades have been living in. Before it went mainstream, we were all knees deep in virtual reality. We already talked about VLANs, all right, and we talked about why am I blanking on them now? VLANs and VPNs, and I feel like I'm missing another virtual, but these are all just different ways of segmenting your network virtually to make it so employees can't mess up somewhere else. All right, it's to help segregate sections of your network. It's very important for security, but also can be very useful if your company has 100,000 different electronic devices and you don't have 100,000 different IP addresses to give. So splitting it up can help because each one of those can be their own private IP range. So to help solve the issue of having all of these big applications running on your operating system, we said, hey, more virtualization. Let's make more simulations of simulations, all right? We are going knees deep in the matrix here, all right? Simulations on top of simulations on top of simulations. So, compartmentalize. Good question, all right? Compartmentalize, let's look it up. It means to divide in sections or categories. For example, I like this picture here. Sections of your house. Not really the best one, but let me find another image here. Why are there so many church ones? It means to break up things into sections, into compartments, and you have them separated from each other completely. All right? Any questions on that? Let's see here. The Matrix is real. The Matrix is real. It's been around for quite a while. We've been using it in the computer space for quite a while. Virtual everything. So much so that it's reached a new limit. This is not on the test, all right? This is not a part about what we need to go into, but it's reached it so much so. Now, NVIDIA has gone mainstream starting I think it was 2 years ago. This is how new and quick everything moves along. That they've started their digital twin product suite. So NVIDIA has a whole product suite for their digital twinning. Digital twinning. This is used all the time at places like Tesla. What digital twinning is literally making a digital twin of every real world thing that you can potentially think of. Typically, it's not going to mimic the entire world, but it's meant, for example, you want to make a self-driving car. What is cheaper for you software-wise? Selling these cars with cameras and stuff equipped, having people drive them, then having them click a button to report back issues or when the system failed, then having someone sit there, review that footage, and then annotate what failed, how it failed in some type of standardized format, then move it along to the next person to then make sure and double check it's standardized, and then pump it to your machine learning algorithm to learn all over again. That's a lot of steps. Screw that. Instead, let's make a virtual reality and call it a digital twin, where we simulate Tesla cars driving on roads with cameras, and now we can make a bunch of challenging situations automatically, and when we run them, they'll automatically be annotated, analyzed proper, and then can be fed directly into the machine learning algorithm. All right, that's what digital twinning is. It's been around, it's growing, it's massive. They're literally making exact replicas of everything as you know it to help run simulations to improve efficiencies. All right, you can go down this rabbit hole. There's a lot here. It's pretty new. It's being pushed pretty hard. All right, so what runs these? Virtual machines run everything. All right, so before we can get into virtual machines, we got to talk about virtual machine monitors, or VMMs. All right, not everyone calls them VMMs. Typically, they'll call them hypervisors. Let's see if we can get an actual Wikipedia article right here for hypervisors. So a hypervisor, also known as a VMM, is basically a lightweight piece of software that kind of works like an operating system. So you'll install this instead of Windows, instead of Linux, you'll install this software on a computer. All its job is to run multiple operating systems on top of it at the exact same time. Those will be called virtual machines. All right, when you have multiple operating systems running at the exact same time within a really small operating system or an actually full-blown version of operating system like Windows, that's going to be called virtual machines. All right, they're called virtual machines because they aren't actually your core machine that's running. They are virtualized little instances of an operating system which is being managed by someone else, by another program, and it looks like to the operating system that it is the only computer that's running there, right? Just like the Matrix. You think you're alive and doing things and eating food, but in reality, you're hooked up to a machine, and that machine is what's, handling everything for you. It's literally just like that, all right? So that's what programs like, for example, we've talked about Docker will do for you. It's a kind of like a hypervisor. Windows also has their own version of a hypervisor called Hyper-V. It's pre-installed on your operating system. I don't think you have access to it unless you have Windows Pro. All other versions will not have access to it. So if you type in Hyper-V, if you have the Pro edition of Windows, you'll be able to look and see your Hyper-V manager, and this is where you can run potentially multiple operating systems on your operating system. But you don't need that. You can use something like Docker and do the same thing. So if, for example, we talked about cloud services like AWS before, there's Google Cloud, there's Alibaba Cloud, there's Microsoft Azure Cloud. All cloud providers will be running these everywhere on all their servers. All right, this is how they're able to give you, for example, a Ubuntu box on some hardware. It's not like they stood up a server just for you. No, you're on the same hardware the same box, the same computer as potentially 100 different people. All right? It could be more than that, it could be less than that. You're sharing it, but you have no clue you're sharing it because you are in a virtual machine. You are separated from each other. Most of these cloud providers will not use the one that Windows made. They'll build their own from scratch typically. So AWS has their own called hypervisor. Let's just Google AWS hyper. There we go. They call theirs Nitro. All right. So this is their hypervisor. Popular ones that people will use would be things like Docker to run on your computer. Another popular one would be the products by VMware. VMware is another massive company that people usually use to run hypervisors. So they've been in a rough spot lately, but one of their biggest customers are going to be governments. So governments for multiple different countries. This is what they'll typically default to. Let's see here. So we talked about any questions on that. And if you guys haven't seen The Matrix, let me pull up the Matrix plugged. Oh God, hopefully this isn't the movie, because I think this is a movie. There we go. All right, here's a picture. There you go. If you haven't seen The Matrix, effectively everyone is living in these little pods here, and they're being managed by robots, and all of them are they never know they're inside of this world, because all they think and see every day is just normal life. All right, but in reality they are all like asleep and a part of a bigger system. That's what a hypervisor does. It puts all these OSs in their little compartment, and they run completely independent and not aware of the real reality of everything. Now, this doesn't mean they're foolproof. All right, you can exploit a VM, and you can break out of it. All right, it's called breaking out of a VM, or breaking out of a container if you were doing it in Docker. And if someone's able to break out of it, it's no bueno, because then now they can traverse to different operating systems that are on the same box. Those exploits are far and few between. They're very, very rare, and usually you've pissed someone off if they're going to use them against you, because the only people that are going to be funding and really looking into that are going to be big hacking groups, typically professional, big, large hacking groups that are going to be using against you to make money, or government organizations that will be using against you to make money off of you or collect intelligence. You're pretty much safe from that. All right, there's not really any common ones that are out there being used. They're pretty much all the known ones are pretty much found, patched, and good to go. This is why it's also important to go utilize something else. It's not really encouraged for you to build your own hypervisor, just like Microsoft doesn't really encourage you to do your own HAL, because there's a lot of things that could go wrong, and it's better if you just pay to use something like VMware's, where they have people monitoring, building, and securing this 24/7, so you can just use theirs and have peace of mind instead of you having to worry about all of that craziness. So virtual machines, we've talked about a lot already. This is what a hypervisor will be running. It's just going to be your operating system. Here we go. Here's a good picture. Your operating system running on the same hardware as potentially multiple operating systems. So this host operating system layer at the bottom is not always there. It depends on the hypervisor, but it's typically just a hypervisor that will be running multiple VMs. And again, hypervisors and VMMs are the same thing. They're just different verbiage for the same thing. Any questions in regard to that? I felt like I've beat it to death. The key thing for hypervisors, or sorry, not hypervisors, for virtual machines and containers, they are different. Virtual machines will be the full entire operating system. So if an operating system is 10, 20, 30 gigs in size, the virtual machine will be downloading and running that entire operating system and filling up RAM as if it was a full normal operating system, right? 100%. Like, it is 100% its own standalone thing. Containers, on the other hand, are very small and very lightweight, and they will not contain a full operating system. They will be the bare minimum of everything that's required, and typically they will utilize some of your underlying operating system's resources to execute or run everything. All right, so containers, small. Virtual machines, they're the full real deal. All right, any questions on that? And we talked about different types of virtual machine monitors already. Let me see if the Google's has anything extra to add in here. This is just for virtual machines. Does that clear up any questions that you had before, Kauai, on some of this stuff? Because I know you were a little bit confused on what was going on. Yeah, we pretty much covered all the major types of virtual VMMs. So, if you guys have any questions, you go and ask them. We've pretty much solidified operating system. We have hit it. We have covered it. We have talked about it. We have gone through it. We have finished it. We are done with it. Thank Jesus, hallelujah. Bring out your praises. All right. So, go ahead and again ask any of your questions. As a quick review, we talked about virtualization. All right. We talked about drivers and where drivers can live and what they're a part of. We talked about being rude on a computer and that it's can be done at the hardware level or the software level, and it's good to handle it. We talked about internal processes like threads and how that takes place and some additional information that's usually attached to them, and you can tap into that as a programmer and see what exactly is going on. We talked about the different designs of several different operating systems and how they function. We talked about file systems and the separate kind of layers in each one of them. We talked about mobile OSs and how stuff like Android, for example, will use virtualization or containerization by default, and then what potentially getting root access looks like on each one of them, and why it's called even rooting in the first place, because it's getting access to root, the user root. We talked about in the Unix world how to set permissions, change who owns stuff. We talked about Vim. We do need to go over environmental variables. All right, so we ain't done yet. We forgot to talk about that one. We did talk about that on Windows. We didn't talk about it on Ubuntu. So let's go ahead and just talk about it real quick before moving forward here. So on Ubuntu, they have environmental variables just like Windows does. How you can see them is they're called path. The path. If we use that handy dandy echo command, we can print this out. So $, all caps path will print out the environmental variables for your operating system here. All right. So this is how you can view the current path on your machine. Now, just like Windows, when we type in a command here, like ch or move or whatever we want to do in the terminal, the path works exactly like it does in Windows. It will look through these directories that are listed here, and in Ubuntu, they're going to be separated by colons. it's going to look through each one of these paths and try to find that program that you're executing. If it can't find it, then it's going to throw a little message and say, what are you talking about? And this is really nice. It will even recommend maybe what you were trying to do in this operating system. But that's what it will do by default. If you want to add more things to your path, for example, Python's the most common one people will have to do it for because it doesn't get added to your path by default. This is where you would add it. Now, Microsoft is really nice because you get that nice GUI. If we pull up environment variables, and when we do that, there's a little button here at the bottom we got to click on for environmental variables, and we get this nice little GUI. And we have to find path, and then we can enter our path in here. We don't get this nice little GUI in the CLI world, all right? We just get this crap. So to modify your path, it can be a little bit tricky for some people, all right? You can't just say your path now add this. You have to use those extra little guys that we've gone over in order to add it, cohere it to it. So for example, we know if we do echo path, this will print out our current path. And that will not work the same for cat path because this is going to be different. All right, this is going to be different than echo because anything with a $sign is a environmental variable that is set. So if we look here, path is one of many environmental variables set on the Windows operating system. It is one of many variables set on the Linux operating system. So we have to use echo. Now we know if we do this, it will print out the path. We need to add something to the end of it. So what we can do is typically people will do echo path, and then you'll add path. We can do it like this. So this again will overwrite everything in this and replace it with the new contents that's getting spread out. So this is a completely delete and overwrite. So if we run this, oh no, please don't tell me I messed it up. Ambiguous redirect. I'm blanking right now on it. So you know what we do when we blank as a programmer? That's right, you Google. All right, this is the real world. You Google, you steal, you cheat. All right, so let's go ahead and let's do Linux add item to path. That works. So how to add a directory to path. If we go and look here, we've already done echo path. We already know that's going to print things out. So let's go down a little bit more. Here we go. And this is what they recommend, saying path is equal to, and you'll see here that we're adding our new directory, colon, and then path. All right, this is re-adding, because remember, we have to re-add what we're doing because the operation of this is completely deleting and rewriting the contents back to the path variable. So make sure, knock on wood, make sure you add the path back in so you can retain the old information. If you don't do that, a lot of things are going to break on your computer and it won't be a very good day for you because you're going to have to add them all back by hand. All right, will not be very fun. Export is required to keep it official because this works very similar to the other command in DOS that we went over that I'm blanking on, it was for PowerShell, alias, where it only keeps it valid for your current terminal session. If you do this, so let's go and try this out. If we do this, it's only going to be valid for our current terminal session. So $sign home is going to be an alias for your home directory. All right, it's going to be the same as if you type pwd. That's another variable that's on your operating system. So now that we added that, if you see, we've now added the directory /home/qfc9/bin to our path at the very beginning. So if we go ahead and echo our $path, you can see that is now here in the beginning. So we've added it. And you can see, again, you have to do the $path here or else it will not work. You want to see what happens if you don't do that? Let's say we forgot that and we ran it. Oh no, I dang screwed up. Everything's broken now. If we print out the path, it's only this. It's all messed up. Everything will not work anymore, right? It's no bueno. Things are not good. This is a big abort mission here. When you use path like this, it's only valid for this terminal session. So if I close this terminal and reopen it, please Windows, don't do anything weird on me here, and rerun this, there we go, you'll see everything is back because it only works for this terminal session. To actually save your changes, you have to put export at the beginning. So that's what it has here, and that's why it's talking about it. All right, sweet. So we covered that. We talked all about absolute relative path on both the DOS, PowerShell, and Linux sections. We talked about all the default folders that you'll get in Linux and what is in each one of them. We talked about a bunch of different commands in Linux and how pretty much there's usually a one-to-one equivalent for other operating systems, and sometimes these will not be on your operating system by default because some of the consumer operating systems will not include them because consumers will not be using some of these commands, like for example ping, netstat, and tracer-t. We talked about man pages and how we all love men now. All right, we all love the man. The man is our best friend, right? We had lots of new friends we met all through Linux. All right, we met elves. All right, we had lots of fun with elves. Oh, Lisa, don't get me started with Lisa. I love her. All right, who else we meet? We learned about how to nuke stuff. We talked about orphans and how it's okay to kill orphans. All right, only in here though, not in real life. All right, we had lots of fun in Unix world, and then we were over in Windows world where it was okay. They're trying to do stuff, I guess, logically or something over in PowerShell, but devs don't like that. It makes too much sense, first of all, and second, look at those letters. Look how much I have to type. Are you kidding me? I'm a programmer. I'm lazy. I don't want to stroke a single key more than I have to, all right? Not unless it's for Lisa, all right? I'll only do that for Lisa. All right, let's move on here. And then we talked about DOS and how DOS was the original base for Windows. It no longer is, but there's legacy stuff built into the operating system, so you can use DOS. Command prompt will run DOS. PowerShell does not use DOS, as we showed. PowerShell will let you run some of the commands, but only because it's aliased with underlying PowerShell commands. All right, I prefer PowerShell. I think you should be using PowerShell. PowerShell also has a bunch of Unix commands aliased also. So I usually just use Unix commands in PowerShell and in Unix because that's what I use most of the time. So it makes most sense. We talked about absolute relative paths again, how you can use do scripting in PowerShell through the ICE. Talked about command prompt. We talked about logs, where those logs are, different types of backup systems built into your operating system, but also that's included in things like databases and other applications you can use. That Windows uses DACLs. Windows has their own proprietary file system. The Windows file structure and what you get by default. And then we talked about some stuff over in Active Domain Land, which you probably have very little experience with in normal Windows world, but when you go to a corporation, they'll be using things like Active Directory and the domain controller to handle accounts and permissions, and that's where all your different groups and members will come into play. We talked about the boot process, so what the actual motherboard will do on your computer first before passing off responsibility to the operating system. The things that are on the motherboard, the steps it goes through, things you can do on your computer like overclocking and underclocking. We talked about how permissions are just an illusion and they're not built into your computer at all. So when things are in the most insane mode where God privs are just running rampant for everyone, that's real mode. And when your operating system finally gets booted up, it will start enforcing permissions, and that's when you're going to be in protected mode. We talked about rootkits, and bootkits are pretty much the same thing. It's just about location of where they are at. We talked about just some general operating system basics, like different operating systems, what even is a kernel, our GUIs and our CLIs, what hardware software is, multitasking, single tasking, single users, multi-user, different types of computation techniques that can be used, other different computation things. We talked about information assurance again, and a bunch of access control list types that you can utilize in your programs. And of course, privileged and non-privileged users, aka Windows administrator or Linux root. Sudo command gives someone root temporarily. Remember that. Any questions on any of this before we move on to programming? He said, lucky Lisa. I know. Y'all solid on this. We don't got any questions? Well, if you do have questions, you can ask on Sunday when we do our normal Q&A chill time. So tomorrow, we're going to get into programming. All right, tomorrow we're going to get into programming. I know we're at the hour here. We're about to just finish and close up the stream. So tomorrow, we're going to get into programming. We're going to start with Python. We're going to do Python first. Then we're going to do some C just to show you guys some of the concepts we've talked about. And we're going to go over C to do that because it's much more of a low-level language. Then we're going to go back to Python, learn more. Then we might touch on Java for a little bit just because, I mean, I hate the language. It should be dead. C# is way superior. But still a lot of jobs use it legacy-wise. But don't worry, most of the people that grew up on it and enforce usage of it are literally dying out or retiring because they are that old. So we'll teach it just because, and then we'll probably go back to Python and finish up with some HTML and CSS training. All right. Any questions on that? So if you haven't done so already, install Python on your computer. If you can't install Python, don't worry. There's like a million sites you can use instead to run Python on. For example, Replit is great. So repl.it, I guess they're also called repl.com now, replit.com. You can make an account on here and follow along with what we're doing on here. All right, they allow you to pretty much program in any language, and you know how they do that? Behind the scenes, they spin up you a Docker container, and you work inside of that. I know, it's all coming back. We're already talking. We can't stop talking about containers, VMs, because that's what runs the world. All right, yeah. So download Python. Remember, we talked about it several times. Python, I don't know why. I don't know why. It's really bad for beginners. By default, when you try to install Python, so if you go over to the Python org site and we go to download, and right here it will have download for Windows or whatever you're on. Click on that and it should download. When you try to install this, I don't, let's see. If I do modify, would it be a repair? Nah, I'm not gonna mess with it. When you try to install it, stop. Just stop, look around. There's going to be a box that's unchecked by default, all right? It's going to be asking you if you want to add Python to your path. Please click that box, all right, and add it to your path. If you already installed it and you forgot that you did, or you don't know if you forgot, how you can test is if you load up something like PowerShell and you type in Python. If you don't enter the Python CLI and you get an error message instead, you messed up. It's okay though. It's such a common occurrence, we have a video for it to help you fix it. So if you go over to our YouTube channel, let's go here. If you go over to our YouTube channel and you can either search for it or you can go down here to videos, there is a video here for either pip is not recognized or Python is not recognized. Let me go in and zoom this in. So we got videos here on how you can learn how to install Python, how to fix that path issue for Python, and then also if you're having an issue with pip, how to fix pip. All right. So you can watch those to figure out what is going on. So if you are lost in the sauce, and this messed up my other thing right here. OMG, that is so annoying trying to figure out that for my first time. Yes, it is very, very annoying. I know why they do it, because typically if you're downloading Python, like you'll have multiple versions of Python on your computer, and so you may not want all of them like added to your path, or you might want one to stay your default one. But like if you're already at that level, like you can figure your own crap out. Like you're just kind of screwing over new people, but we'll see here. Let me check. All right, sweet. That's all I got. So I will see you guys tomorrow and we'll start getting into Python and write our first program. All right, we're gonna write our first program together. Awesome, awesome, awesome. I'll see you guys on the next one.